boys. Thank God for failure and the things I couldn't do. So much of my life, it's all I ever knew. Thank you for failure in my teen music, for making the dreams that chose me come true.
Hello, boys and girls. You may be wondering what I am doing, running around with a fly swatter and with cow poo, rotting meat, honey, and dog poo sitting on this table. Well, I will tell you. My name is Klondike Charlie, and Mr. Shannon has hired me to teach you about the scientific method. So, I have gone around and collected some samples of stuff that stinks, or that flies might be attracted to, either way. Anyways, I hate the fly. So do Mr. Shannon dogs. So, we trap the flies. Ha 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 ha. We trap the flies, yes. We trap them very good. And after we trap them, they die and they don't bother the dogs anymore. So, the scientific method is a way to understand the world. It's what scientists do. They gather information and they test and they have evidence to explain what is going on. So, I will teach you. I will teach you very good. The scientific method. Let us begin with step 1. Step 1 is we must ask a question. We must ask a question. What must we do? Ask a question. So, I will ask a question. My question is not, am I crazy? Because yes, I am. I am crazy. I'm crazy. So, what I want to know is which smell attracts the most flies. If you buy the fancy fly trap from the store, you see and you smell how successful it is. It catches a lot of flies and it stinks very, very bad. So, I want to know and I want to construct my own fly trap. So again, my question that begins everything, because I'm curious, is which type of smell attracts the most flies? I have the meat. Doesn't that look good and tasty? Delicious, yes? I have the honey. Ooh, very nice, yes. Honey. And I have the dog poo. Finally, I am also testing the cow poo. The cow poo, yes. We test the cow poo as well. So, here we go. Oh my gosh, these flies are terrible. These flies are terrible, yes. So, form a hypothesis. Form a hypothesis. A hypothesis is a testable prediction. If I do an experiment, it's what I think will happen. So I put it in if-then statement. If-then statement. If I set stinky stuff out on table, then I think the flies will be most attracted to the meat. That is my hypothesis. 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 Not hypnotism. No, not hypothermia. Hypothesis. So, let's see. Next step 3. Step 3. 3 is to test the hypothesis. So, I need to test. How do I test? I do an experiment. And I find a really good experiment. But a good experiment have to have 3 main things. An independent variable, a dependent variable, and constants. So, first, I think, what is my independent variable? What is the one thing out of all of this stink, all of this great experiment, what is the one thing that I am controlling? What am I changing? What am I testing? What am I testing? Do you know? It is the type of smell. I am changing. The one factor I'm changing is the smell. I am changing the smell. So, the next thing is what I need to measure. And that we call the dependent variable. The dependent variable is what we measure. What am I going to measure in this experiment? I am going to measure the number of flies that land on each plate in 1 hour. I am measuring the number of flies. I am measuring the number of flies. That is my dependent variable. Constants. It is the same weather. It is the same time of day. We have free access to flies. All of the things that must remain the same. They are on the same plates. The plates were the same before I put the stink on them. What else? What else? Constants. Things that must remain the same. The temperature, the wind, all of these things get the same conditions. The only thing that is attracting the flies is the smell. Okay? Okay. So, independent, the type of smell. Dependent, the number of flies. Constants, the plates, the weather, the sun, the time of day, the flies. Where the flies are coming from. All of these things are constants that I remain the same. So, I also, with my experiment, need a step-by-step reproducible procedure. Which means I go one thing at a time. Step 1, gather up the stinks. Step 2, put the stinks on the plates. Step 3, put the plates in the sun. Step 4, watch and record the number of flies that land on the plates per hour. That is my experiment. After I conduct my experiment, is study or analyze your data. So, I gather my data, I count my number of flies, and after I count my number of flies, I can put that data into charts and graphs to better see trends, to see the results in a more organized way. So, if I make a graph, I would have 45 flies on the dog poo. I would have a bar that goes up to 45. My next bar would be the honey. And for the honey, let's say we have 65 flies in an hour. The cow poo only has 15 flies per hour. But the rotting meat, oh my goodness gracious, sweet sassy molassie, these rotting meat attracted 263 flies in an hour. It was amazing. Tons of flies, tons of flies, tons of flies, tons of flies. Oh my goodness gracious. Unbelievable. So, after I make my graph, I have studied my data. I can see trends. I can see what is happening. the last step of the scientific method is to form a conclusion. In my conclusion, I say, does the evidence support my hypothesis? Now let's go back and remember what my hypothesis was. My hypothesis was that if we put the stinks outside, then the most flies will be attracted to the rotting meat. And if I look at my data does support my hypothesis, because the most flies were with the rotting meat. So instead of saying, yes, I was correct, I say, the evidence does support my hypothesis. The next step is to indicate sources of error. Where did I go wrong? Where did I go wrong? How could this experiment be even better? Well, one thing is, do I look at the number of new flies? I could make it very, very, very scientific and have rooms with flies in the room and nothing else in the room except for one plate with the stink on it. Here, flies can go from one thing to another, and you can see how they prefer the rotting meat. But if I just had one room for each different type and the rooms were identical with the lighting and the temperature and everything, then that would be more scientific, and I could carefully count how many visits the flies make to each of them. So, the last step in the conclusion is to think, can we retest this? Can we do this again? If I would do this at night or in the shade, how would it affect? Also, I can think, what other questions have I come up with? I wonder, I spent some time in Wisconsin while visiting my other cousins, and I see the flies on the cow poo all the time. They're there constantly. And, I have on my sawdust cologne so they don't bother me, of course. But the flies, maybe this is old dry cow poo. Maybe there is flies attract to different freshnesses of cow poo. So that arises a whole new question, and I could begin the scientific method all over again with just cow poo, and the independent variable for that would be how fresh the cow poo is. And I could check flies again. So, many different ways to do scientific method. Here, flies, cow poo, honey, dog poo, rotting meat. We see results. We better understand the world. Maybe one of the main ingredients in the stink for the commercial fly trap is some kind of rotting meat. Delicious.
Something that I wanna know, just a fire come